warm good morning to dear class 10ers. Hope all of you are fine and safe. After a short break, again we are here with the continuation of our online classes. So from today onwards, we are going to start the third phase of our online class. Hope all of you will enjoy it. In the last class, just before your knowledge-based online exams, I have started the chapter Refraction through Lenses. So continuation with the same chapter. Today I will discuss it about the formation of images by the lens. So before we go through this, let us consider an object which is placed in front of a lens. Now when the object is placed in front of a lens, the light from the object, it passes and it falls on the lens and it gets refracted. That means the light coming from the object, when it falls on the lens, the light rays get refracted. And when the light rays get refracted, these refracted rays will produce the image wherever the refracted ray they intersect or they join or they meet at a point, or they appear to meet at a point. Okay, so let us consider an object which is in front of a lens here. Okay, so this is the lens, object is in front of the lens. So now from the object, the light rays, it passes and falls on the lens. And from the lens, the light rays get refracted. And when the light rays get refracted, okay, wherever that refracted light will meet or they appear to meet, in that point, the images are formed. Okay, so in order to produce the image, we have to draw a ray diagram. A ray diagram is very important, it's very necessary, okay, in order to where the images are formed, about the characteristics of the image, what are the size of the image, where the images are formed. Okay, so all these to know the characteristics of the image, you have to draw the ray diagram. So to draw the ray diagram, you will draw only two rays. Okay, two rays. Two rays means one ray which is coming from the object and another ray which gets refracted. That means the two rays is necessary. One ray, when you draw one ray, and that ray is considered as incident ray, and that incident ray will fall on the lens. And once it falls on the lens, the ray of light will get refracted. And when the light rays get refracted, they will meet at a point, one particular point, or they will appear to meet. So that point will form, and in that point the images are formed. Okay, so these are the points you need to remember. Now let us consider the lenses. Let us consider the first lens, that is a convex lens and a concave lens. Now in case of a concave and convex lens, okay, now what happens now is that now the straight line is the principal axis. On the left hand side is the first focal point, right hand side second focal point. Whereas in a concave lens, on the right hand side first focal point, and in the left hand side second focal point. So this is just opposite, okay, in case of concave and convex lens. Now let us consider a ray of light coming from the object, and this ray of light is parallel to principal axis. Okay, when the ray of light is parallel to the principal axis, after refraction it passes to the second focal point in case of a convex lens. Okay, remember that a ray of light parallel to the principal axis, after refraction passes to the second focal point. Similarly, a ray of light which is parallel in case of a concave lens. Okay, so what happens is that the ray of light it appears to come from the second focal point. In case of a concave lens, what happens here? It appears to come from the second focal point. So this is the first condition to remember. That means when the ray of light is parallel to the principal axis, in case of a convex lens, the ray of light passes to the second focal point. In case of a concave lens, a ray of light parallel to the principal axis appear to come from the second focal point. Second one, when the ray of light passes through the optical center, when the ray of light passes through the optical center, the ray of light emerges out without any deviation. There is no any deviation. There is no any change in the path of ray of light. The ray of light will not change its path or its direction. So when the ray of light passes through the optical center, it emerges out without any deviation, both in convex lens as well as in a concave lens. So this is the second condition. And third one is here. When a ray of light passes through the first focal point, in case of a convex lens, when a ray of light passes through the first focal point, after refraction, it goes parallel to the principal axis. Okay? When the ray of light passes to the first focal point, after refraction, it goes parallel to the principal axis in case of a convex lens. Then second one, when the ray of light it seems that the ray of light is passing from is coming from the first focal point. That means these rays of light, it seems that these are this is the incident ray, refracted ray. Okay, this is the incident ray, refracted ray. So what happens is that now this refracted ray will appear to come from the first focal point. That is in case of a concave lens. Okay, so here actually in convex and in a concave lens, so what you observe here is that the refracted ray actually they are intersecting. Okay, and images are formed here. Images are formed wherever the refracted ray will intersect or they will appear to intersect. In a convex lens, the refracted ray will actually intersect, whereas in a concave lens, the refracted ray will appear to meet or they appear to come from that point. So these are the three things you should remember when you draw the ray